Good evening, everyone. We are Team ARGOS, and our mission is to safeguard India's coasts. The problem is urgent. 40% of India's 7,500-kilometer coastline is eroding. The distribution of sand grain size is a direct predictor of this erosion risk and dune stability. However, current manual beach surveys are incredibly slow, costly, and dangerous. They can cost up to 5 lakh rupees per kilometer and are unsafe near high tides. We need a better, smarter solution. Our proposed solution is the development of a low-cost camera-based automated beach sand grain size mapping system. Our solution is ARGOS, the first AI-powered rover that predicts coastal erosion in real time. It is faster, safer, and up to 10 times cheaper than existing methods. ARGOS is an autonomous rover that maps the key terrain zones, the berm, dune, and intertidal areas, and classifies sand grain size. Critically, it combines onboard AI with real-time data to provide a predictive early warning system for erosion risk. What makes it truly unique? No existing solution combines a rover, AI, GIS, and live tide APIs for this purpose. ARGOS uses an end-to-end pipeline. Rover collects, AI analyzes, cloud stores, dashboard visualizes, users act. On the rover edge, using low-cost components like the ESP32 camera and various sensors, it captures images, measures slope, and retrieves the tide forecast. This is where onboard pre-processing happens. The data then moves to a cloud server and ML pipeline. Here a Flask backend runs the grain size segmentation and model inference. Data is stored in a Supabase and results are rendered. Finally, the user layer provides a React website dashboard and a Flutter mobile app. This is where users see real-time data visualization, interactive maps, and crucial erosion alerts. The ARGOS system is highly feasible and viable. Technically, it's built with low-cost modular components like a Raspberry Pi and operates offline, syncing data with the signal returns, ensuring reliable field deployment. Software feasibility is proven with Flask for AI inference and real-time tide API integration. Economically, ARGOS is revolutionary. Our estimated cost per unit is only 13,000 rupees compared to imported solutions at 20 lakhs or more. This leads to a 70 to 80% reduction in survey costs. This makes it perfect for our target market. Government bodies like NIOT and MOES and private sectors such as ports and resorts tapping into a 200 crore addressable market in India. The impact of ARGOS is massive. First, it offers speed, giving instant AI results versus weeks of manual analysis. It's highly scalable and deployable nationwide. And most importantly, it saves money, greatly reducing survey cost and manpower. For communities, it means safer coasts through predictive tide risk alerts and enhanced disaster readiness. For policymakers, it provides a low-cost, accurate, and scalable monitoring tool. ARGOS is not just a technology. It's a commitment to protecting our environment, supporting sustainability, and building disaster resilience for India's coastline. This framework shows the core image processing pipeline we use in our sand grain classification project. We start with raw microstructure images and enhance them using techniques like extrapolation and contrast adjustment to ensure edge clarity. To improve accuracy, we use data augmentation and tile the images with overlaps so no detail is missed at the borders. A unit model then segments the individual sand grains, and we refine the result using post-processing steps like hole filling and watershed segmentation. The final output is a clean grain mask, which we use as a foundation for classifying the grains based on their size, shape, and texture.
This is a 6-wheel independent suspension rover prototype, where each arm adjusts dynamically for uneven terrain, ensuring stability, traction, and adaptability, perfect for exploration and testing application. It's equipped with IMU, GPS module, a camera. All the data is sent to the cloud in real time or can be stored on an SD card for areas with no internet connectivity. A rover can be manually controlled or set to auto run mode, navigating using tight API data.
The Coastal Rover Monitoring System is built for quick intelligent coastal monitoring. It has four key modules. The dashboard gives instant telemetry like battery level and distance. The map view shows live GPS tracking with coastal zones and supports data export. The Analytics tab visualizes historical trends in grain size and moisture, and Missions lets operators plan future mapping runs easily. Built on a modular Flutter framework with a robust backend, it ensures real-time updates, accurate data, and smooth performance. The interface is clean, minimal, and intuitive, designed so even non-technical field users can operate it effortlessly. In short, it delivers real-time oversight, smart analytics, and precise reporting, helping coastal teams assess erosion and terrain stability with unmatched efficiency.
This is a unified dashboard built to monitor, map, and analyze coastal erosion in real time. Our rover autonomously collects field data, which is instantly visualized here on the dashboard. The dashboard provides a snapshot of key metrics, which is the average grain size, the tide level, the rover status, and the last mapping cycle. The AI model continuously updates these readings as the new data comes in from the rover, ensuring decisions are backed by live and accurate information. You can see on this map that the rover has mapped the data points, and we can connect them to map the GPS and terrain data. And then clicking on a zone will reveal its local readings like the grain composition, the tide conditions, and what kind of readings are performed using the image over there. Over time, these layers will build up a complete GIS map of the coastal dynamics. The report section automatically compiles daily and weekly erosion summaries. It converts the raw sensor data and image data into structural insights such as average sediment shift or moisture variation depending on the erosion hotspots. The images section just shows the analysis of all the images that were taken by the rover, and it is updated continuously as the rover works through. Then we have the control panel. This is the command center for every rover that is used. From this page we can view the rover battery, the connectivity, and issue the movement of the rover, which would be forward, backwards, or hold based on the tide levels and the terrain slope. We can also just set it to automatic so the rover can map it automatically by itself. And then we have the exports page, which will allow users to download the complete data set, the correlation, the grain size charts, and the zone maps in CSV or GeoJSON formats.